Hi everyone, this is Janine aka Janine the Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, and university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt quickly. And as a way for us to help you students stay on top of your studies, we are offering and running daily classes and their free classes for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, I will be going over calculus and vectors. So we'll just continue off from where we left off from the other class. Okay, great. So since we left off at part D, this is where I will continue. And as you can see, we are running out of space, so this will be moved. Before we get started, I just want to know if you guys can see my screen and also if you can hear me coming through. If not, please let me know. If you're from Facebook or YouTube, please comment down below. Okay, great. So to start off, we have limits right here, and you have u raised to the power of 3 over 4 minus 64 over u minus 256, right, as u approaches 256. So as you can see, if you remember from my previous class, if you haven't watched that, please do rewatch that or watch that. So if you have radicals involved, right? So in this case, you have an exponent and you know that it's in a form of a fraction, you need to think about substitution right off the bat, right? Because you want to be able to change this radical and then simplify things further. So we can actually simplify u raised to the power of 3 over 4, right? And u on the other hand, because you're changing the variable essentially because you're substituting. So that means let u be equal to, let's say, w, right? And then on the other hand, because this is u raised to the power of 1, right? We also have u raised to the power of 3 over 4, right? Which is what we wanted to simplify. We're going to say that this is w raised to the power of something, right? So over here, if you have u raised to the power of 1, right? And then this is w raised to the power of 1, you're going to think of sort of a ratio between u raised to the power of 1 and u raised to the power of 3 over 4. So how can you turn 1, right? And this 3 over 4, right? So this is 1, and how can you turn this into 3 over 4? So let's say if you have, I guess, 9 right here, and then if you have 12 right here, so maybe we can turn this into a whole number, right? Because the goal here is we want to get rid of that radical. So essentially, we want to have whole number exponents, right? So for 12, right, if we have 12 divided by 9, right, that's going to be 4 over 3, right? So maybe I can give some space. Okay, so if you're coming from 12, right, to 9, right, so if you think about this, you're going to have 12 divided by 9, right? So 12 divided by 9, we know that it's 4 over 3, right? So over here, right, we're just making a ratio between u raised to the power of 1 and 3 over 4, right? So as you can see, you're going to have this ratio. Actually, if we do 3 raised to the power of 4, I think this would be better. Let's say, yeah, okay, 12 to 9, right? So 12 times, actually 12 divided by 9 would give you 4 over 3. So that's the ratio that we will be using. And then essentially anytime you're seeing u raised to the power of 3 over 4 and u, you're going to substitute that with w raised to the power of 12 and w raised to the power of 9. Okay, so let's go. So here you have u raised to the power of 3 over 4, right? So we said that this 3 over 4 is w raised to the power of 9. And then you have minus 64, right? And over here, underneath that, your denominator, we know that this is u, therefore this is now going to be w rather, raised to the power of 12 minus 256. Does that make sense? And then we're just going to take the limit of that as, now because it's u, right, to begin with, we need to change this into w, right? So let's see, because this is 256, right? All we have to do is plug in u, right? So we know that u is 256, and this is equal to w raised to the power of 12. And as a result, because we want w, you need to take the root of 12, right? Of both sides. Does that make sense? Because you're substituting, therefore you still need to remember that if you're changing u into w, then therefore your u approaching 256 should be 12, well, root of 12, right? And inside here you have 256. Okay, w and right there. Okay, so this is 12 and you have 256. Okay, there we go. So if you have w raised to the power of 9, for example, and you have w raised to the power of 12, right? As you can see, if you remember, we have the formula difference of cubes, right? What is the difference of cubes? Well, it's a cube minus, right? Remember this formula? And then essentially, we can say that this is equal to a minus b times a squared plus ab. Okay, so keep in mind that because it's a difference of perfect cubes, right, in this case. So here you have minus, right? This has to be minus, right? And if this is plus, then therefore this has to be plus, and then you're just going to switch the signs, right? So if this is minus, now this is going to be plus. And this is going to be plus b squared, right? Is this clear? Okay, maybe let me just move that. Okay, great. So now if we have this, right, so we can actually start by saying that this w raised to the power of 9 is expressed as w raised to the power of 3. And then you just have to make sure you have this bracket, raising this to a power of 3 again. Remember your exponent rules. And then you have minus, okay, because this is 64, right? You need to think of a number which you can actually raise it to an exponent, right? Which needs to be 3 as well, right? Because that's the goal. So maybe if we think about having 4, right? Because if you have 4, and then if you try raising this to the power of 3, it's going to give you 64, right? So if we have 4 and then you enclose that into a bracket, raised to the power of 3, you would end up with 64, right? And over here, maybe this 12, we can turn this into raised to the power of 2, right? So you would have w, right? And this is now 6 because you need to have the difference of perfect squares, right? So if we're using the difference of cubes here, right? That's what we're doing here. Now, for your denominator, because you can't really express 12 as cube, right? I mean, you could. It would be w, then you have raised to the power of 4 times 3, right? But 56 is going to be a problem for us. Therefore, it's just easier for you to have this in perfect squares, right? So this is going to be minus, and we know that 16 times 16 is 256. So we can just say that this is 16 raised to the power of 2, and therefore you're going to get 256, right? So we can actually rewrite this again, right? So we know what the formula is now. So we have w, right? We need to write this in terms of a minus b, right? So remember what a minus b is. So a minus b, so a is right here. So a is cube, right? And then your b is 4, right? So that's what we're writing essentially. So w cubed, right, minus 4, then you're multiplying this to a squared. So when you square this, this now becomes w raised to the power of 6, right? Because 3 times 2 is 6. Plus 4, right, w cubed. So we're just essentially multiplying a times b, right? So 4 times w cubed plus 16, right? So 4 times 4, because 4 squared is 16. And then underneath that, you're going to have w raised to the power of, so again, as a recap, the formula for this, for difference of perfect squares, you would have a minus b, right? So a squared minus b squared is equal to a plus b times a minus b. Okay, great. So again, our A is W raised to the power of 6 and your B is 16. So if you have W raised to the power of 6 plus 16, you multiply this to, let's see, W raised to the power of 6 minus 16, right, over here. And then you can see that this W raised to the power of 6, right, we can actually further simplify this, right, because it's still going to be, well, you can still express this as a difference of perfect squares, right? You can rewrite this as W raised to the power of 3, then you enclose that into raised to the power of 2, and then you have 16, which is 4, right? Okay, great. So okay, so I'm just gonna have this right here. Okay, let me just move this up so you guys can see that. Okay, great. So rewriting this again, so we're going to have W raised to the power of 3 minus 4 in your numerator multiplied to W raised to the power of 6 plus 4W cubed plus 16. So I'm not changing anything in my numerator. However, in my denominator, I'm also copying this W raised to the power of 6 plus 16 because you can't really simplify that. And then I'm multiplying this to W raised to the power of 6 minus 16, but I'm changing this into, right? So instead of saying W raised to the power of 6 minus 16, we can actually say that this is W raised to the power of 3, right? Squared minus, well, we know that if you take the square root of 16, this is going to be 4, right? So 4 squared, right? So essentially, we're still applying this formula right here. Great. So now that we have that, we can say that this is A, right? W cubed plus B, right? Which is 4. Then you multiply this to W cubed minus 4, right? As you can see, the reason why we're doing this entire step of substituting is because if you plug in 256 to begin with, right, you're going to result to an indeterminate form. So you don't really want an indeterminate form when you're taking the limit, right? That's why we're applying this limit, which is a technique in order to get rid of the indeterminate form first. And that's why we're substituting, right? So remember, whenever you have an indeterminate form, you need to always think about factoring, right? If you can factor things, if you can cancel them out. Secondly, if you can have, let's say, substitution, right, as a way to kind of cancel out things and simplify before you direct substitute. And then lastly, we're going to get to end behavior in a bit. So those are your limit techniques. Okay. I think when you're studying calculus, this is just my tip based on my experience and the way I like to learn things. Maybe it may be helpful for you as well. Try to study limits in a way that you're grouping the techniques because I think it's just easier for you to just look at the problem and be able to assess whichever technique that's going to be the best, right? So over here, right, you can cancel this. And you can actually say that this is W raised to the power of 6 plus 4 W raised to the power of 3 plus 16. And this is over W raised to the power of 6 plus 16 multiplied to W raised to the power of 3 plus 4. Make sense? Cool. So again, we need to apply this limit, right? Because we're supposed to take the limit. And we're still keeping W. So now we have limit as W approaches root of 12, which is 256, and then you have W raised to the power of 6 plus 4W cubed plus 16 over, so I'm just simply copying this over here, and this is W6 plus 16 multiplied to W cubed plus 4, right? Great. So now that we have here this simplified form, when you substitute this 12 raised to the power of 256, you can just plug this into your calculator. You should end. So that's your limit. Great. So that's how you're going to find 3 over 16. Okay, cool. Again, you don't have to keep on writing things down because honestly, I'd rather you understand this. So just make sure to check out the recordings because everything will be recorded, including what I've written down as my worked out solution. So make sure to check that out on oneclass.com/livestream. Okay, so moving on to the next question. I think there was one question left for limits before we proceed to the next one. Okay, great. Okay, interesting. Interestingly, we have an absolute value, so this is a good practice. If you have any idea how to start this question, please make sure to comment down below just so I can check whether you guys are actually understanding this. So what do we do? So here's my question. What do you do if you have an absolute value? What is the first thing that you need to apply in order to break down your absolute value? Okay, great. So just to follow up with my answer in terms of what's the first thing that needs to come to your mind when you're dealing with absolute values and when you're taking the limits of them, you need to break them down into piecewise functions, right? So I'm going to just break this down into piecewise functions. So remember how in an absolute value, you're looking at the negative side, right? Because there's a reflection. And then you're also looking at the positive side, right? And because you're dealing with 4, that means you're looking at when x is greater than 4 and when x is less than 4. So maybe we can start off with x is less than 4, right? X is less than 4, that means you're taking the negative component, right, of your absolute value, right? So we're still going to have 16 minus x squared over, however, we're going to open the bracket of your absolute value. So we're going to get rid of this absolute value, essentially. And we're going to have negative, right? And you have 4x minus 16. On the other hand, because we're looking at x greater than 4, that means you need to write this as positive now, right? So it's 16 minus x squared over 4x minus 16, right? And that's it. So that's your positive and your negative. So remember, absolute values, piecewise functions. Yeah, okay, great. Piecewise functions. So that's the first thing you need to do for absolute values. Actually, limits of absolute values, rather. Okay, great. So now that we have that here, right, so we can go ahead and expand this, right? But the only thing that we really need to worry about at this point is because we're looking at the positive side, or as you know, if you remember, if you have 4 plus, right, that means you're looking at what happens when you're at the right-hand side of 4, right? Okay, so maybe we can draw the number line here. So the number line is right here, and you have 4, right? So the question is, if your x is approaching 4 plus, right? So what that superscript means is you're looking at what happens here, right? So you don't really need to look at anything that is less than 4. Therefore, we're only going to focus with this one, when x is greater than 4. Okay, that's what we need to look at. Otherwise, if this was x approaching 4, if it's simply 4, then that means you need to look at both, right? Because you're looking at both the left-hand side of 4 and the right-hand side of 4. Okay, does that make sense? Hopefully that wasn't too bad. Okay, great. So if you have 16 minus x squared over 4x minus 16, that means you can actually simplify this, right? And you can break this down into the difference of perfect squares, right? Remember the formula? If we went back to this, here's the difference of perfect squares. You need to express that as a plus b times a minus b, so that's what we're going to be doing here. Great, so we have this. I'm just going to write this here again. Okay, and rearrange this again. So we're going to take the negative sign out, right? So we can have the a squared minus b squared form. So this is negative x squared, right? As a result, you're going to see that this is minus 16, right? Taking the negative sign out would cause 16 to become negative. And guess what? We can also take the 4 out, right? 4. And then you have x minus 4. Okay, cool. And then from there, we can actually further simplify this, right? So we can say this is x plus 4 times x minus 4, right? Because remember, difference of perfect squares. Dividing both sides, sorry, not both sides, but in your denominator, you should have 4. And this is being multiplied to x minus 4. Okay, great. So once we have our piecewise function, right, we were looking at x greater than 4, we can cancel this, right? So now we see that this is negative x plus 4 over 4, right? And then all we have to do is plug in 4, right? direct substitution after. So x plus 4, and this is over 4. So we're going to look at the limit as x approaches 4 from the right hand side or right side, and then you have negative x plus 4 over 4, right? So plugging in 4, right, direct substitution, you're going to get negative 4 plus 4 over 4, right? So this is negative 8 divided by 4, which is going to give us negative 2. Great. Okay, so that's it for limits for now. Okay, so let's move on to, so I finished D&E, which is going to be available again on another sheet, right? So, okay, great. So moving on to number 3. So we need to differentiate, right? So we need to find the derivative of each of the following, and then we need to simplify our answers. Great. So as you can see from the first question, we have two terms, right? Well, not two terms, but we have two like brackets here. So this is one pair, and then this is another pair, right? So that means you need to either apply your product rule, right? Remember, if you're taking the derivative of your product rule, right, you need to take the derivative of the first one multiplied by the second term plus the derivative of the second term, right, multiplied by the first term. Or it's either you apply the FOIL method. But because it's my preference, right, to apply the FOIL method first, so that means you need to expand this because you need to simplify your answers, right? So here's the thing. The reason why I'm applying the FOIL method is because it's just easier for you to simplify things right off the bat, right? But if you don't need to simplify this, then you can go ahead and apply your product rule, right? So remember, math is all about making sure that everything is right, but we want to be as efficient as possible, right? So again, there's going to be a lot of ways that you can solve this problem. Okay, great. So remember what I said, I'm applying the FOIL method, so here we go. So we have 8x raised to the power of 4 times 5x. So that would give us 40, x raised to the power of 5, right? And I'm multiplying negative 6 times 8, so that's negative 48, x raised to the power of 9, right? And we have the inner function, right, which is 4x times 5x, so that would be plus 20x squared. Then you have this 4 times negative 6, that would give us negative 24, and you have x raised to the power of 6, right? Is that clear? Okay, cool. So now that we have that, right, that means we need to go ahead and take the derivative, right? Because we just expounded our function. So the first derivative of whatever this is, okay, so we need to apply the power rule, right? So what's the power rule? You need to multiply 40, right, times 5, right? Because you're bringing down your exponent. And then as a result, you need to subtract your exponent by 1, right? So 5 minus 1 would give you 4. So that's how you're going to find the derivative of the first term, right? So, okay, let's go. So this is 40 times 5. So that would give us 200, x raised to the power of 4, right? And then you have minus, right, 48. So minus 48 or negative 48 times 9, that would give us negative 432. And this is x raised to the power of 8, right? And this is going to be plus 20 times 2, that's 40x. And finally, you have negative 24 times 6. So that's equal to negative 144. X raised to the power of 5, right? So that's your first derivative in that case. Okay, so that's simplified, right? Because you don't really have any like terms, and that's it. Okay, great. So okay, let's move on to part B. So we have y is equal to 2x cubed minus 3 over 2x cubed plus 3. And remember, this is raised to the power of 21. So guess what? We need to apply the chain rule, right? So for the chain rule, don't worry, it's not too bad. All you have to do is make sure you break out or you bring your 21 down, right? Because this is sort of like an exponent, and then you're going to subtract this by 1, right? So the chain rule just states that you're going to bring down your exponent, right? So 21, right? And whatever is inside, you're going to keep that. So you have 2x cubed minus 3, and then this is going to be over 2x cubed plus 3, right? So whatever is inside, you're going to keep that, and then you're taking 21 minus 1, right? So, or any of your exponent really, if it's 5, then you're going to subtract 1. So 21 minus 1 is 20, right? And then this is the time you're going to expound and find the derivative of your inner term, right? So make sure you deal with the outer term first, which is the 21, and then you have to deal with the one inside. And as you can see, because you're dividing two things, you need to use the quotient rule, right? So quotient rule is basically taking the derivative of the first term, or your numerator. You multiply this to just the second term, which is your denominator. So this is 2x cubed plus 3. And then you're subtracting, right, the derivative of your denominator, which is 2x cubed plus 3. You're multiplying this subsequently to 2x cubed minus 3, which is your numerator. And then you're taking your denominator and you're squaring that. So 2x cubed plus 3 squared. That's it. Okay, and we're done. Okay, so because we have to simplify this now, this is going to get a little bit tricky, right? However, if it's just taking the derivative, then we're done, right? And then we all have to just make sure that this is going to be 6x squared, right? And this as well. Okay, so let me expound on that. So this is 21 times 2x cubed minus 3 over 2x cubed plus 3. And this is raised to the power of 20. Then maybe I can just take the derivative of this. So 2 times 3 is 6x squared, right? The derivative of a constant is 0. That's why this is 0. Then you multiply this to 2x cubed plus 3 minus, this is 2 times 3, right? Which is 6x squared, because 3 minus 1 is 2, plus 0, multiplied to 2x cubed minus 3. And this is going to be over your denominator, which is 2x cubed plus 3 squared. I don't recommend you expounding or expanding your denominator because maybe you can cancel things out in a bit, so that's why don't expand. Okay, so now that we have that, okay, I guess we don't have enough space again. Copy. Just so we have a copy of the question before we get started. Okay, great. Okay, I'm just gonna write the question because apparently it doesn't want me to copy. Okay, 2x cubed minus 3, 2x cubed plus 3. Okay, so this is the question. So let's turn this into black. So y is equal to 2x cubed minus 3 over 2x cubed plus 3, and this is raised to the power of 21. Okay, so that's the question. So going back to this, remember we need to simplify this, so that's what we're going to do now. Okay, so what I recommend you doing now, let's see, is basically split this up into two terms, right? So instead of having just one bracket raising this to the power of 20, you can actually turn this into 20 and 20 individually, and then you're going to add your denominator, right? So this is now going to be 21. Then you have 2x cubed minus 3 raised to the power of 20 over 2x cubed plus 3. And this is raised to the power of 20. Then you're going to add this and this essentially. 6x squared, 2x cubed. So I'm not changing anything in my numerator first. And you have 2x cubed minus 3. And this is going to be 2x cubed plus 3 raised to the power of 2. Okay, so here we go. We're adding these two, right? So this is 21, 2x cubed minus 3. And this is raised to the power of 20. And then in my denominator, I'm adding, remember these two? Maybe I can go and highlight that. So adding this and this, right? So we have 2x cubed plus 3, and this is now 22. Okay, so now that we have that, we're going to see that we have the 6x squared left. And this is 2x cubed plus 3 minus 6x squared. And you have 2x cubed minus 3, right? Okay, so now is the time that you should be expanding, right? So here, if we expand this, so I don't have to write this again, you're going to make sure you apply the distributive property. Then you have 6 times 2, which is 12, right? X raised to the power of 5. And then you have 6x squared times positive 3. So that would give you plus 18x squared. And this is going to be minus 6 times 2, which is negative 12x raised to the power of 5, right? And then this is now going to be positive 18x squared, right? So as you can see, the 12x raised to the power of 5 cancels out. And then you're left with 18x squared, which is 36, right? 18 plus 18 is 36. So we have 21, 2x cubed minus 3 raised to the power of 20 over 2x cubed plus 3 raised to the power of 22. You multiply this to 18, well, it's 36 now, right? 36x squared. Great. So now that we have that over there, okay, so 36, yeah, all we have to do is multiply 36 and 21. So that's going to be 756, right? So this is 756, and this is going to be x squared. Then you multiply this to 2x cubed minus 3 raised to the power of 20, and this is over, well, the whole thing is over, 2x cubed plus 3 raised to the power of 22. Okay. So we've done x squared, making sure we didn't leave anything. Okay, great. So that's our final answer. 756 x squared times 2x cubed minus 3 raised to the power of 20 over 2x cubed plus 3 raised to the power of 22. Great. Okay, let's go back to the last question. Okay, so it says here, find the equation of the tangent line to the graph y is equal to square root of 5x squared plus 4x at x is equal to 45. And don't forget, we still have this question at the bottom. Okay, so for this question, because we're looking for the tangent line, right? And guess what? We need to find the slope, right, of the tangent line in order to figure out what the tangent line first is, right? So because they're giving us y is equal to square root of 5x squared plus 4x, you need to find the derivative of this y, right? Because the derivative of this y would tell you the slope of your tangent line. And then all you have to plug in is the 45 later on, right? So in that case, we need to find the first derivative. So here we have the chain rule that we need to apply, because remember, this is a radical, so therefore we know that this is actually 5x squared plus 4x, and this is raised to the power of 1/2, right? So that means we need to bring down the 1/2, right, and turn that into a coefficient. So that would be 1/2 times 5x squared. Remember, we're going to literally just copy whatever we have inside the root. So that's going to be 5x squared plus 4x, and then we're taking our exponent and subtracting that from 1. So that would give you negative 1/2, right? And then that's the time you go ahead and find the derivative of your inner term. So in that case, that would be 5 times 2, right? Power rule, right, in this case. So this is times 10x, and this is plus 4. Okay, great. So now that we found, like the first derivative, right? So maybe we can organize this in a way that we can simplify things, because we need to be plugging in and writing the equation of the tangent line. So in that case, you have 10x plus 4 over 2 square root of 5x squared plus 4x. And as you can see, we can actually cancel out the 2 by factoring the 2 first. So we have 2, 5x, and okay, let me just scroll this down a bit so you guys can see what I have. There, go. Okay, so we have 2 times 5x, and this is plus 2, right? And this is over 2 square root of 5x squared plus 4x. And also, I just wanted to say hi for the people who just came in. And if you do have any friends who might be interested in, like just joining us for a calculus class, please call or text them and ask them to join. Okay, so going back to this math question. So we know that this is 5x plus 2, which is over square root of 5x squared plus 4x, right? So we know that this is the slope, right? But we're not yet done because we have x is equal to 45, right? So that means we need to plug in 45 to find what the slope is, right? Or what the value of m is in this case. So we're going to say that this is m of 45 and this is equal to, so maybe we can bring this here. So we have 5 times 45 plus 2, and this is over square root of 5 times 45 squared plus 4 times 45, right? Okay, so 45 times 5 plus 2 is 227, right? Yeah, 227, and then in your denominator, right? I don't recommend you typing the whole thing in your denominator, your numerator, and both your denominator in your calculator, because it's going to give you a decimal, I believe, depending on what calculator you're using. So maybe we can just do this manually. So 5 times 45 squared. So that would be plus 45 times 4. So the one inside your root is actually equal to 10,305, right? So the root of 10,305, right? So we can simplify this. Remember, when you're trying to get rid of your radical in your denominator, all you have to do is multiply both your numerator and your denominator with the radical, so you can actually get rid of the radical. So this is 10,305 divided by square root of 10,305, and then you can see that you can get rid of the radical, right? So this is 227 square root of 10,305 over 10,305. Great. So that's our slope, right? By the way, right beside 45, this is actually m. So just bear in mind that, okay, maybe I can change that and move that a little bit. Okay, I didn't mean that this is equal to this, right? You get the point. This is basically that. Great. Okay, I'm just going to separate that. Okay, great. So once that we have our slope, right, all we have to do is set up our equation of the tangent line, and I'm just using y is equal to mx plus b. Okay, so y is equal to m. We know that m is 227. Then you have square root of 10,305 divided by 10,305, right? This is x times x plus b. Okay, so we're not yet done because we don't really know what b is, right? So therefore, we know that x is equal to 45, so this has to be 45. And then for y, right, all we have to do is find y based on our function, right? So all we have to do is plug in 45 and see what our y will turn out. Okay, let's do that. I'll use a different pen, purple. So if we plug in 45, right, in our x, so 5 times 45 squared. Yeah, this is 45, not 9. Okay, you get the point, guys, right? So this is 45 squared plus 4 times 45. Okay, great. So square root of 5 times 45 squared plus 4 times 45. This is, okay, this is going to give me a decimal number. So maybe we can manually do this. So what I mean by a decimal number, when I plug in the whole thing, which is the root of 5 times 45 squared plus 4 times 45, I'm getting 101.5, which is definitely a no-no because in calculus, right, even if you're in high school, I think your teacher most likely wants you to express this as a root, right? So 5 times 45 squared plus 4 times 45, you should end up with 10,305, right? So the root of 10,305. So that's your y, right? So this thing is your y. So that means you're going to plug in y over here, which is 10,305. Maybe I can move this a little bit. Okay. So again, we're just using this, right? We're saying that this is 10,305 and the root of that, and then we're saying this x is 45. And then we're solving for b, right? So when you have that, we're going to say this is 10,305. Then we're moving this to the opposite side of the equation. So this is going to be negative 227 times square root of 10,305 over 10,305 x, which is 45, right? And this is equal to b. Does that make sense? So I'm just making sure that when I transpose this to the opposite side of the equation, I have the negative value of whatever this is. Okay, so let's see if we can try to simplify 45 and 10,305, right? And 227. So maybe we can just figure out the coefficients first. So we have 227 times 45 divided by 10,305. So I'm getting 227. So when I simplify this, I will highlight that for you. So when I simplify the yellow terms, right, that means this is 10,305 and this is minus, I'm getting 227 over 229, right? And this is basically square root of 10,305, right? And that's equal to b. Okay, so from there, we can actually combine our terms, right? So we can actually multiply square root of 10,305 times 229 and make sure it's just one fraction as opposed to two. So, okay, so we're multiplying this, right? The butterfly method, right? Okay, so 229 times square root of 10,305. So this times your denominator, which is 1, right? So denominator is going to be 229, and then multiplied by the negative sign right here, multiplied by, remember this is over 1, right? So this is 227, and you have 10,305. Okay, so now we have like terms, right? Because we have the same radicals, so we can just say 229 minus 227. Let's see. 229 minus 227 is 2, right? And this is equal to b. So we can say that b is equal to 2, 10,305, and the root of that, and this is over 229, right? So that's b, because you can't really simplify 2 divided by 229 even further, so we're just going to keep that as b. So let's go back to writing y is equal to mx plus b, since we know what b is, right? So again, the equation of your tangent line is equal to y times m. Our m was this, right? 227 times the square root of 10,305 divided by 10,305 times x, right? Plus b. So this is our b. 2 square root of 10,305 over 229. Great. Okay, cool. So that's our equation of the tangent line, not your typical tangent line. So what I mean by that is typically if you're looking at a tangent line, it's pretty straightforward like this, but this is actually pretty hard, I would say. Okay, cool. So for part B, as you can see, it says if the tangent line is parallel to 2x minus 6y is equal to 32, right? Actually, this is supposed to be a question. So if you go back to this, right, so it says once we have this, right, y is equal to square root of 5x squared plus 4x. So we want to figure out if the resulting tangent line from part A, which is this thing, is this parallel to this line, right? So what does it mean when something is parallel, right? So think about when two lines are parallel, what is the same among the two lines, right? So if two lines are parallel, that means, if you remember from middle school, the slopes need to be the exact same thing, right? So first, we need to figure out what the slope is of 2x minus 6y is equal to 32. And then we need to confirm whether that's the same as what we have in our tangent line. Okay, let's use a different color. Let me try orange. Can you guys see this? Okay. Okay, so we have 2x minus 6y is equal to 32, right? So I'm just writing this down again and making sure that, you isolate y and you have the y is equal to mx plus b. So we have negative 6y, and this is equal to negative 2x, right, plus 32. So I'm moving 2x to the opposite side of the equation. That's why I'm getting negative 2x. Dividing both sides with negative 6. So you end up with y is equal to, so this becomes positive now, and this is 1 over 3 x, and 32 divided by negative 6 rather, this is negative 16 over 3, right? So we don't really care about this y-intercept. All we care about is the slope, right? So we can say that the slope that we need to be looking for is 1 over 3, right? So we need to watch out for 1 over 3. Okay, so once we have 1 over 3, we can say that the slope of this is 1 over 3. Now, we need to confirm whether that's also the slope of what we had in the beginning, right? So if you have 1 over 3 over there, and remember what the formula is for, actually not the formula, but the equation that we wrote for the slope, right? So we said that the slope, so going back to part 4, because these two questions are pretty much related. So we said that the slope had this equation, right? Let's highlight that in orange. Okay, we said that this is 5x plus 2. And this is over square root of 5x squared plus 4x, right? So literally, we just need to copy this. Okay. So we have 5x plus 2 over square root of 5x squared plus 4x, right? So we need to equate this 1 over 3, and this needs to be exactly the same, right? Which is equal to 5x plus 2 over this thing, right? Because we need so going back, for these two lines to be parallel, they need to be equal in terms of slope, right? That's what we're doing. So we're taking the equation of our slope, right, from the first part, or part A, and we're equating that equal to 1 over 3, right, which is the slope for the second line. So cross multiply, right? 5x plus 2 times 3, so we're going to have 3 times 5x plus 2. And this is equal to 1 times the square root of 5x squared plus 4x. Okay, maybe we can expand this. So expanding this, it would give you 15x plus 6, right? And this is equal to the square root of 5x squared plus 4x. Because we want to get rid of this root, that means you need to square this, right? Squaring both sides with 2. Well, yeah, when we're squaring, it's raised to the power of 2, right? So in that case, we can get rid of this, right? And remember a plus b squared, like from the Pascal triangle, that formula, which is a squared minus 2ab, or plus rather, because this is plus 2ab plus b squared. That's what we're going to apply here. Okay, let me just write that here. So this is equal to 5x squared plus 4x, and on the left-hand side, we have a squared, so that's 225, and x squared plus 2 times 15 times 6, that's equal to 180, right? 180x, and 36, right? Because 6 squared is 36. Okay, great. So we have that. Now we need to isolate, actually we need to combine these two equations, right? From the left-hand side and the right-hand side. So we have 225, right? Subtracting that from 5x squared would give us 220 x squared. And then you have 180 x minus 4x, right? So that's going to be minus 176 x, and lastly, this is 36, is equal to 0. Okay, so guess what? We need to apply the quadratic formula. So if you don't remember what the quadratic formula is, right, we need to find what a is, what b, and what c is. So essentially, they're all our coefficients. So a is 220, b is negative 176, and finally, 36 is c, right? And the formula for the quadratic equation, or actually quadratic formula, is negative b plus or minus square root of b squared minus 4ac over 2a, right? So negative, right, times negative 176 plus or minus square root of b squared. So in that case, that would be negative 176 squared minus 4 times 220 times 36 over 2 times 220. Okay, maybe we can just deal with the one in our radical first, or the root. So negative 176 squared minus 4 times 220, and this is times 36. So you're going to get a negative number, and as you can see, if you remember, we can't have a negative number inside a root, right? Especially in a square root. So that means this is no solution, right? You can't have this, and you can't really factor this because this is plus or minus square root of negative 704, and this does not happen at all. So that means you don't have any solutions, therefore this is impossible. So 2 times 220, just to finish that off, 440. Okay, because we have this, therefore there's no solution. And going back to the question, if they're asking us if the tangent line is parallel to 2x minus 6y is equal to 32, it's an impossible scenario. Some of you are probably frustrated right now, so doing all this work, and you're probably saying, did you just say that this is impossible? So we did this for nothing? Well, I mean, I guess that's the beauty in math, right? Sometimes you just need to do and solve it in order to find the right answer. Okay, great. So, okay, let's see. I think we finished off from the first live stream. Yeah, we did finish the whole live stream one, I think. Yeah, we did. Okay, great. So for the next few minutes, I would say, let's try to finish this. Or maybe let me pick the question that we can actually do in a couple of minutes left. Okay, so because this is going to be a long one, that's why I've left so much space. We can try number 2 first, just to end off the class, because we don't really need to simplify things. But I want you to kind of familiarize yourself in terms of differentiating, right? So for part A, right, we have f of x is equal to something, right, which is the term raised to the power of 6 over 5. So as you can see, that means we need to apply the chain rule, right, because it's a term and close in an exponent, right? So based on the chain rule, if you recall, that means you're bringing down your exponent, so it's 6 over 5 multiplied to the one inside, right? 2x cubed plus 7 over 2x cubed minus 7. And then you're taking 6 over 5 minus 1. So this is 1 over 5, right? Okay, and then from there, once you have 1 over 5, you need to find the derivative of your inner term. So in that case, you're multiplying. So in this case, because we need to apply the quotient rule, right? So first the chain rule, then the quotient rule, right? So what's the quotient rule? You need to multiply your numerator, right? Take the derivative of that times your denominator, which is 2x cubed minus 7, minus the derivative of your denominator, which is 2x cubed minus 7. Then you multiply this to your numerator again. So essentially you're alternating, right? So you're taking the derivative of your numerator first, multiplied by your denominator, just make sure you have a minus sign, right? And then you have your denominator, take the derivative of that multiplied by your numerator. And then you're squaring your denominator as the last step. So you have squared. So in this case, maybe we can simplify this part first, right? So 6 over 5, then you have 2x cubed plus 7, and then you have 2x cubed minus 7 raised to the power of 1 over 5. Okay, so here's the thing. A lot of students, they tend to stop in this step, right? But think about it. You haven't really finished finding the derivative of your numerator and this part, right? So make sure you actually do that before you kind of move on to the next question. So 2 times 3, that's 6x squared, right? And we know that the derivative of 7 or any constant is 0. That's why it's 0. Then you multiply the 2x cubed minus 7. And then this is minus, right? Taking the derivative of 2x cubed is actually 6x squared, right? 2 times 3, because we need to bring down 3 because it's the power rule, right? 6, and you have x. 3 minus 1 is therefore 2. The derivative of negative 7 is 0 because it's constant. Multiply to 2x cubed plus 7 over your denominator, right? 2x cubed minus 7 squared. And because we don't really need to simplify, which is amazing, that means we need to just say that this is our final answer. Okay, the 2x cubed minus 7 squared is not part of the answer. Maybe I can move that down. Okay, there we go. So for part B, let's see. So we have 2 radicals, which is interesting. Okay, so that means we need to apply the chain rule simultaneously, and that's a 2-step. Okay, 3 more minutes, we got this. Okay, so taking the first derivative, right, over here, that means chain rule, right? So you need to deal with your outer function first. As you can see, it's basically the 5x squared, right, with that square root. So that means you're going to have 1/2, and before we even, find the first derivative, that means you need to, I think it's easier for some students if you write this out in terms of exponents as opposed to having the square root, because it gets a little bit confusing. So I tell my students that it's okay to take this step by step. So if you have 5x squared inside and then you have something else, right? So maybe this is 21x cubed minus 9x squared plus 4x. And we know that this is also raised to the power of 1/2. It's just easier for some students, and it's fine, right, to have your exponents written down as opposed to it's a square root, right? Because in that case, if you have, your exponents expressed in fractions, it's easier for you to know, okay, I need to bring down 1/2 as my coefficient as opposed to having a square root, which sometimes it gets a little bit confusing. Great. So you have 1/2, right? And as you can see, because it's a very tedious and long process, it's really important to really take your time to really figure out like how you're going to approach the question, because I think it's just worth it, because if you're really fast, but if you're inaccurate, then that's even worse, right? So make sure to do whatever you're comfortable with during the test and even when you're just doing your homework, right? So this is 1/2, and you multiply this to 5x squared, and this is plus 21x cubed minus 9x squared plus 4x raised to the power of 1/2. And remember, this is what I tell a lot of my students: don't feel compelled to rush things, especially in math, because it's not a race, right? It's a marathon. It's basically the way you're going to get to your right answer, right? That's basically the key point whenever you're solving a question. Okay, so this is equal to, right? Now that we've dealt with the outer function, right? So we have 5x squared plus 21x cubed minus 9x squared plus 4x. And this is times 1/2, right? We first have to deal with 5x squared, right? So remember, once we take this 1/2, apply the chain rule, we need to deal with whatever's inside. So this 5x squared, right, when we take the derivative of that, that would be 10x. Does that make sense? So that's 10x. And then that's the time you need to apply the chain rule again, right? Because you're going to this term right here. Does that make sense? So sort of PEMDAS, right, or BEDMAS, you're going to apply that, right? So parenthesis first, right, which is your 1/2, and then whatever is inside, right, the bracket. And then you're going to deal with this thing, right? So we have 10x space from here, and then you're going to have plus, right, which is going to be 1/2 because you're bringing your exponent down. And guess what? This is going to be a long one. Just make sure that this is combined, because I don't have enough space to write down the whole derivative on this part. That's why I'm bringing the plus 1/2 down, right? So just imagine that this is times 10x plus 1/2, right? So just imagine that. This is continuous, okay? So this is plus 1/2 because we're dealing with this. Maybe if I highlight this, it becomes easier. I don't know. Okay, cool. So that's the 1/2. And then remember, we dealt with the 1/2 coming from the one outside. So that's here. And actually, this is from here, right? Okay. Great. So once we have that, we're going to expound this thing, right? So this is basically times 21x cubed, right? Remember, chain rule, you're just supposed to copy whatever's inside while you're bringing your exponent down. And, oh, and make sure this is negative 1/2, right? Because this is 1/2 minus 1. So chain rule, bring the 1/2 down. Make sure your exponent, you subtract that with 1, you get negative 1/2. And then the same thing applies here. You're bringing down 1/2, then you have 21x cubed minus 9x squared plus 4x. And then making sure that this 1/2 minus 1 is negative 1/2, right? Okay, great. So that's part of that. And make sure that after this, you need to follow up with whatever's inside, right? So that means you're taking the derivative of 21x cubed minus 9x squared plus 4x. Okay, so 21 times 3, that's 63, right? 63x squared. And then you have minus 18, right? 9 times 2 is 18. 18, and this is x, right? Because 2 minus 1 is 1. That's why it's only x. And lastly, you have plus 4, right? Okay, great. So I think we're done because we pretty much expounded everything. So we started off, again, as a recap, we started off with the yellow one because it's the outer function. So that's 1/2, right? We bring down our exponent applying chain rule, and then we just copy whatever's inside, which is exactly 5x squared plus 21x cubed minus 9x squared plus 4x raised to the power of 1/2, and making sure that if you have this 1/2, right, this 1/2 is minus 1, that's why it's negative 1/2, right? Chain rule, when you're taking the derivative, you need to make sure your exponent, you subtract that with 1, and you get negative 1/2. Subsequently, or following that, you're multiplying your inner function, right? The derivative of your inner function, that would be 10x, right? And then you have plus, right? We need to find the derivative of your inner function, which is this, but we need to apply chain rule first because that's what's outside your inner function, right? Which is 1/2. And remember, this is the same thing as what we did for the yellow one. So we're bringing down 1/2, and then we're having 21x cubed minus 9x squared plus 4x, and making sure you subtract again your exponent with 1. That's why it's negative 1/2 over here. And lastly, you need to find the derivative of your inner function. And in that case, your inner function would be 21 times 3 to give you 63, right? And guess what? This is x squared. See, double checking is good. Okay, so 21 times 3, that's 63, and that's x squared minus 9 times 2, right? That's 18, and then you have x, right? Because remember, 2 minus 1, which is 1. And then lastly, because this is x, so 1 minus 1 is 4, therefore, when you take the derivative of 4x, it's just 4. So, this is your derivative in the unsimplified version. Okay, great. I hope this class, you found this helpful. If you're interested in, attending classes with me on a regular basis, or because this is daily, right, for math and chemistry, please visit oneclass.com/livestream. So this is where you're going to see my schedule, including the schedule of amazing teachers and educators out there. So it's not just me doing this initiative, right? We do have a diverse group of educators. They're talented, and they're also doing live streams daily for math and chemistry from grades 11 to first year college and university. If you do have any friends, please tell them to join. I mean, the more the merrier, right? So yeah, thank you so much once again for tuning in, and I'll see you on my next class. Bye, guys.